Now,
Good afternoon, everybody. This is Jim from Savage 4x4. We're going to go over a couple things about gear ratios and gear installation and just information, basic information on gears. You guys come up here just a little bit. I want to show you this right off the get-go. These are called spider gears. Right in here, you have outbounds and you have idlers. All right? These idlers make the contact point in the middle here to the outbounds. All right? Now if you look really close in here, you're going to notice there's teeth missing off the idlers. All right? And you're going to notice a little bit of a wear pattern on the outbounds. That is from wheel chatter. That is from spinning an open differential. This is an open differential. There's no posi in it. There's no limited slip. Basically, whatever this wheel feels, it will transfer it to this side. If this gains traction on this side, it transfers it all the way to the pinion up front. And we'll get into that in just a second. But basically, what you have here is you have wheel chatter. Our good friends from Maine, Sarah and Rafe Harlow, like I said, good friends. They wheel this Jeep. They tell me about it all the time. They show me what they do. They do wheel it. They spin tires. They do a little bit of crazy stuff. They're not being disrespectful. They love their Jeep. They do what they got to do with it. But this is still from wheel chatter. He was about to lose his whole differential because once these teeth come off, they start getting into your ring and pinion, whether it's thrown up inside the carrier area, up here in the pinion area for the oiler, or it gets inside the teeth, or both. And then it causes mass destruction from bearing failure up here in the pinion or teeth breakage down here. There's a couple different things that happen, and I'll show you a second set. But this is a gear failure due to wheel chatter, not necessarily wheel stoppage or what we call impact, but probably chatter. You know, they're spinning the tires and maybe one spinning, the other spinning, and one spinning, and it's just chattering, so it's causing the fracture. You guys follow me up here. So what we got here is a bunch of different pinion sizes, carriers, posi units, open differentials, stuff like that. Let's start over here. We were talking about chatter. This has been sent off and magnafluxed. It shows distress points in the magnafluxing that showed that the metal was stressed. The metal was stressed due to wheel shock. Basically, same thing that happened on that differential over there that happened here, but everything was transferred through to the pinion. This pinion lines up just like that. Now if you look at this, there's no damage on this except for maybe a couple little scar points here and there, just a couple small ones. All this destruction happened on the pinion. If it was due to improper setup, it would wear the pinion, wear the ring and the pinion at the same time, causing destruction possibly. There is no wear except for a couple scald marks that was caused by the teeth from this. Also, an indication of how something like this gets broke is there's an oiler up in here that I showed you on the other differential. As this thing's spinning, fluid becomes almost a solid matter. When it's spinning, that 130 weight, 90 weight oil becomes very, very dense. As this broke under rotation, it grabbed the teeth. Here's the bottom of the case say. It grabbed the teeth and threw them into the oiler up here between the pinion inner bearing and outer bearing. They were all up here except for 1/4 inch by 1/2 inch tube. So that tells me this was broken under load, under stress. Shock stress, that is. Also, like I said, we did send this out to the manufacturer. They didn't want to warranty it because it was due to customer error. We try to accommodate all possibilities of damage on a vehicle before we say no to a warranty call or something like that. But that's a dead giveaway of tire shock. I knew it before we even sent it out. Enough about that. This is a Dana 90. Look at the size of this. Then you got a Dana 60. Then you got a Dana 44. Then you got a Dana 30. I bet you can guess which one is the strongest out of all four of these. And there's a couple in the middle here that I didn't show. A Dana 35, there's a Dana 80 that goes right here. But pretty much, this covers all parameters of what you're looking at. You start throwing a big tire or a lot of RPM or a lot of stress on this little itty bitty gear, it's not going to hold up. It's not going to last. That's beside the point. We just try to build things around here at Savage 4x4 that gets the customer through what they're going to do in a safe kind of way. Doubtful you're going to break something like that. That's got to be 15 pounds solid metal as opposed to 2 to 3 of this. We're going to get to a little bit of description about preloads and backlash as we go through this. We did a little infomercial yesterday. This is a Yukon Tazi unit. It is preloaded. It doesn't have spider gears. It is preloaded, throws pressure on the clutches that are buried in here and over here to create a posi situation. So you always have traction to the left or right hand side of a vehicle. It will absorb a lot of shock that caused this. A lot of shock because the clutch are forgiving. They will slide or slip because it grabs. Not always. You can break axles. You can actually twist axles. Axles look like this on the end. The splines get kind of twisted. You can disorientate them. You can break them. But basically, this is a little bit of a protection for that kind of stuff. So this is a brand new carrier from Yukon with Yukon Premium 488 gears on this unit. The last one we did was 456s. This is a Dana 30. Much, much smaller. Much, much easier to break. That's why people beef up their axles to make a little more strength. Alright? So, let's go over meshing. Here's your 44. Here's your ring. Here's your pinion. Before these things break in, their steel has not been tempered. Some brands out there are tempered, which is a heating process. You heat it up, you cool it down. You heat it up, you cool it down. It makes them harder, makes them last. Right now, this is pretty soft material. It hasn't been tempered, it hasn't been heated up. So there is, as much as you look at these gears in here, yes, they are curved. They look flat, but they're not flat. In the middle of this tooth here, and on this side, they have a slight dome to them. Same thing here. So what happens when this is meshed up here, just like so, and it's rotated, braking period on a vehicle, it does wear away surface areas on the heel and on the toe, or on the load and the coast side of a gear. That will individualize a pattern on a gear set that is designed for this particular vehicle. You cannot really change a gear set from one vehicle to another because gear patterns have been made on these gears to match the specifics of this vehicle. We're human beings. We set them up the best you possibly can with using gauges and a paint pattern that we mark on this to measure backlash, which is the play you get between the two bearings this way. You get a backlash. On an average, you're going to spend, let me think, probably around 8 thousandths. Let's just say a ballpark of 8 thousandths for backlash on this here. That gives a little bit of slack in here for bearing break-in, for gear break-in, so that you can have a proper pattern worn in on this. Like I said, you get a pattern cut on this side, this side, this side, and this side of a gear. Hence, makes a bunch of powdery metallic residue in the bottom of your carrier, your open differential, that you have to pull out. That's why we change fluids after about 500 miles, because you have braking material that you don't want to get into your bearings and your races after everything has been broken in. There's also an additive that is added into a posi or a limited slip clutch type differential that keeps it from chattering as it rotates and slips. It's basically a fish oil. It's a real thin lubricant that goes in this. It's a synthetic blend on a lot of ways, but basically gives it an anti-slip. All right? That's your basic braking period of a gear. Meshing, backlash, preload on the bearings, and I'm going to get into that in just a second. Preload on the bearings, okay? let's go over here. This is a used Dana 30 out of this Jeep right here behind you. Come on in closer here. Let's show you this here. See how shiny? They started out like this. Very dull, no pattern, no shininess, no nothing. See how dull they were? Now they're nice and shiny. Why? Because they're broke in. Alright? This ends up being the same way. If you can look at this, very, very shiny. Which means the surface area has been broken in, been tempered and whatnot. Okay? Typically a factory uses a pre-hardened gear so you don't have to worry about a break-in period. Alright? Break-in periods are key. Can you buy preheated gears? Yes, you can. The thing is that pattern that is so important here and here, you try to mesh it now on this, it might not match perfectly. So, you might get a little bit of hum, a little bit of a roar, but that's just typical of a or should I say a preheated heated gear, because it's already somewhat meshed and already hard. It will somewhat break in. I would say probably about a third of the way these break in. About a third. You're still going to have a little bit of material on the bottom, but it is pre-hard. Alright, the most important thing, let's talk about preload. So what we have here is a pinion with the outbound bearing and the internal bearing right behind the head of the pinion. Alright, this sits inside the unit, the throat of the differential. This is a crush sleeve. This is a mechanically crushed, this is a used one. You can't see a whole lot of difference between the two. If even I held them up here, we'd have to actually mic it. So, this sleeve, once we go in there, we have to crush this sleeve exactly down to the size. See how these things are tapered? That this thing is snug in the hole between the races, as the races are equally tapered. So the bearing sits right inside. Okay? Sits right inside. Now, once again, this is not preloaded by far. So what happens is we drive this in place with an impact or a torque wrench. We bring it in and we crush this sleeve down so it bottoms out on this bearing race here, and bottoms out on that bearing race. That gives you the bottom end of your torque specs on a pinion. After that's done, then you come in with the nut and you tighten it down. So basically what happens here, this bearing does not move. Once it's in there, it does not move. This bearing can always move. It is on this thing, it's not supposed to move, but typically we're just going to call it a movable bearing. It's resistant up against this, makes it stop. The resistance on this side is a nut. I don't have the nut. On the back side here that stops it here. So basically what you do is you create a situation where your bearing comes in and stops, and then it also stops from going outbound via the nut. That is what you call preloading. At about 18 inches out with a wrench, the average preload, it's a little more when you get up to a differential like this, but the average preload on a Dana 44 or a Dana 30 at 12 to 18 inches, I want to see somewhere between, let's just say an average of 15 pounds, which means basically at this far out, 15 pounds with just a finger push down will move this bearing in rotation. That's how much resistance you need. Alright? So, that is called preload. That will allow the chromoly surface of this bearing, I don't know if you guys can see this or not, to break in, this is a used race, into the surface area of this chromoly race. The pattern is much different as you go all the way around on this thing, but this bearing race is already broken in for the bearings that came off of this. You cannot reuse bearings, you cannot reuse races. It's not the proper way to do things, period. You cannot reuse gears because they all become basically built and worn in for this particular application. So we pretty much went over what breaks gears, what other things can happen with gears as far as the idler spider gears and whatnot, the different gear sizes for vehicles. This is out of a 1 ton. This is out of a 3/4 ton, basically. This can go in a 3/4 ton also, but more or less for like a Jeep half-ton, stuff like that. This is pretty specific for a vehicle that doesn't have a whole lot of towing. It's front-wheel drive, not front-wheel drive, but it has four-wheel drive with front wheel. This is basically in the front wheel of the drive unit. So that's pretty much where we're going to be at. Hopefully that kind of explains a few things. Want to give you the point A's and the do's and don'ts. So just want to let you guys know. Have a good day.